Okay, today we're going to go through a couple of examples on the difference of squares pattern when multiplying binomials. So you can recognize the difference of squares pattern because the terms are exactly the same but the signs are opposite. So actually the second terms are opposite. So when we go through, we're going to use the prior knowledge of distributive property and combining like terms. 2y times 2y, that's going to produce a perfect square of 4y to the second. And then we send the 2y all the way down to give us negative 8xy. Once we're done with the 2y, now we can move on to 4x, and we distribute 4x into every single term in the second binomial. That's going to give us that's going to give us an 8xy, a positive 8xy, and then lastly we're going to get a negative 16x to the second. So what you'll notice with our like terms, as opposed to the square of a binomial, in a difference of squares we have opposites. And when we combine opposites, that's always going to give us a 0. And so they end up canceling out. So what we're left with is 4y to the second minus 16x to the second. So what you end up with is the perfect squares, and then our middle terms cancel out. So we can generalize that practice. A plus b times a minus b, we get the square of the first terms and the square of the last terms. We don't have a linear term because the opposites added to 0 and canceled out. So after you get enough experience, you'll start to get more efficient with your product, and we recognize the difference of squares pattern that exists. We square the first term to give us 4y to the second, and we square the last term to give us negative 16x to the second, because we know the linear terms cancel out. It's called a difference of two squares, difference for subtraction, and we have two perfect squares. So we have a difference of two squares.